Welcome back to the channel. Today, we are stepping straight into the surgical theater. Imagine putting on your scrubs, adjusting those intensely bright overhead lights, and picking up your precision instruments. Because let's be real, when it comes to the Cambridge AS and A-level mathematics 9709 syllabus, specifically that notoriously tricky mechanics section dealing with Newton's laws of motion, you absolutely cannot afford to have shaky hands. You need surgical accuracy. You need to dissect these examination questions with absolute, unflinching precision. That means identifying exactly what the examiners are hunting for, isolating those core variables, and applying your formulas with a steady, calculated intent. Today, we are going to look incredibly closely at two of the most fundamental, seemingly basic equations you will ever encounter in your mathematical career, F equals ma and W equals mg. Now, I know what you're thinking. They look simple, right? They look like the kind of formulas you remember all the way back from your 0580 of 4024 days. Formulas you can just glance at and casually plug a few numbers into. But listen to me carefully. That casual, overly confident approach is exactly where thousands of incredibly smart students bleed marks every single exam session. I see two types of candidates all the time. First, you've got Alex. Alex walks into the exam, sees a mechanics question, and totally overloads the paper with raw mathematics facts. Just dumps a dozen equations onto the page with absolutely zero analysis. Then you've got Sam. Sam is panicked about the clock. Sam rushes the reading time, completely misses the specific command word requirements, and misapplies the entire context of the physical system. Neither Alex nor Sam is getting the A-star. So prepare yourselves. We are about to break down the exact step-by-step strategies that transform a flawed rushed answer into a perfectly executed top-tier response. I want you to really absorb this quote. A senior Cambridge examiner recently noted, and I quote, "Most students lose easy marks on Newton's laws of motion, specifically F equals ma and weight W equals mg. But after this explainer, you won't be one of them." It's incredibly ironic, isn't it? We are talking about foundational concepts. These are not massive, terrifying, multivariable calculus equations that stretch across 3 pages of your answer booklet. Yet these incredibly simple formulas are consistently highlighted in the principal examiner reports as the exact places where the most unnecessary marks are lost. Why does this happen? Because students like Sam rush, and students like Alex fail to analyze. They leave easy marks on the table because they don't have a strategic framework for approaching the paper. They just react. Today, we stop reacting and we start executing.
Here is our examiner's playbook for today's session. Number 1, the F equals ma exam trap. Number 2, core theoretical foundations. Number 3, the method mark strategy. Number 4, execution and problem solving. And number 5, top examiner warnings.
Let's get right into section 1, the F equals ma exam trap. It is genuinely fascinating how the Cambridge mechanics syllabus tests not just your ability to crunch numbers, but your ability to read carefully and decode terminology under pressure. So why do students find the distinction between key terminology so incredibly hard? I want you to actively think about this for a second. Put yourself in the exam hall. When you look at a question involving an object moving on an inclined plane, or maybe an elevator accelerating upwards, what is the very first thing that goes wrong? According to the senior examiners, the fatal error is that students blur the lines between mass, weight, net force, and applied force. They see the word mass in the prompt and immediately write down a force. They see weight and treat it mathematically as a mass. This is the ultimate exam trap. It's the dangerous assumption that just because you know the letters F, M, A, W, and G from your earlier 0606 or 4037 syllabus, you automatically understand the causal relationships between them in a high-pressure, A-level environment. But knowing the alphabet doesn't mean you can write a best-selling novel, right? And knowing these letters doesn't mean you're ready for Cambridge 9709 mechanics without a rock-solid, unbreakable grasp of the definitions. You need to decode the command words. If the question says show that, you can't just write the final number. If it says calculate, you need the numerical process. Sam misses this every time. Don't be like Sam.
Moving on to section 2, core theoretical foundations.
Okay, let's dive deeply into this. The theoretical architecture of Newton's laws of motion rests on extremely precise definitions. If your foundation is cracked, the entire mathematical house you are trying to build on top of it will collapse the absolute second the examiner applies any pressure. Let's be totally clear. F equals ma and W equals mg are entirely distinct concepts. They are not interchangeable. Mass, denoted by that little m, is an intrinsic scalar property of an object. It literally does not change whether you are sitting in a Cambridge examination hall in London or floating in deep space. It is just the amount of matter. Weight, however, denoted by W, is a vector. It is a specific, downward-acting force caused by the gravitational acceleration g acting upon that mass. When you write down F equals ma, that F is the resultant force. It is the net force acting on the object that actually causes the acceleration a. It is not just one random force you picked from the diagram. The principal examiner reports make it abundantly clear. The top-tier candidates, the ones securing those A stars, are the ones who recognize these precise definitions, who understand that a net force causes an acceleration and not the other way around, and who demonstrate cross-topic integration. That means they can seamlessly link kinematics equations, like v squared equals u squared plus 2as, with Newton's laws of motion to solve a complex, multi-stage problem without breaking a sweat.
And this brilliantly illustrates what Cambridge is actually testing across 3 distinct cognitive domains. This isn't just about math, it's about how you think. First, we have knowledge and understanding. Do you actually know the raw facts? Do you know the formulas? Second is application. Can you take that raw fact and use it in a totally unfamiliar context, like a particle connected by a light, inextensible string passing over a smooth pulley? And third, the highest tier, analysis. Can you break down that entire system into separate free body diagrams, separate the horizontal and vertical components, and evaluate the entire scenario mathematically? To hit all 3 of these objectives, top students use what we call the PEAL framework. Point, evidence, explanation, link. You make your mathematical point, you provide your evidence by showing the working, you explain the physics context, and you link it back to the specific command word in the question. Examiners are actively hunting for evidence of all 3 domains in your working. If you're acting like Alex, just throwing a chaotic mess of raw knowledge onto the page without any application or analytical structure, you are hard capping your grade at a C or a D. Before we continue, subscribe to our YouTube channel Ace the Exams at actheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Let's transition into Section 3, the method mark strategy.
Listen up, because this is quite literally one of the most powerful tools in your entire exam arsenal. It is the subject specialist's ultimate tactic for Cambridge examinations. When you are taking a rigorous, multi-part 9709 paper, the final answer on the bottom line only represents a tiny fraction of the total marks available. The vast bulk of the marks are awarded for the procedural process, for your logic, for your strategy. So, the crucial point here is show your working. The principal examiner reports issue a massive glaring red alert about this every single year. Students lose ridiculous amounts of marks simply by not communicating their internal thought process onto the paper. Think about it. Even if you get incredibly stressed, your hand slips, you press the wrong button on your calculator at the very last second, and your final numerical answer is completely wrong, method marks can and absolutely will save your overall grade. If the examiner can look at your paper and see that you correctly resolved the forces parallel to the plane, that you successfully applied F equals ma, and that you correctly substituted W equals mg into your algebraic equation, they will reward you. You get the marks for the journey, not just the destination.
To really lock this concept into your brain, let's look at a direct contrast. We're going to transform those red pen marks into green check marks right now. On the left side of the screen, we have the flawed approach. This is exactly what Alex does. A student jumps straight into the heavy math without establishing any physical context. They just write down an isolated number, like 42 newtons, that seemingly appears out of thin air. There's no diagram, no declared variables, nothing. If that number is wrong, the examiner has no choice but to give a 0. Why? Because there's no evidence of logical thought. Now look at the right side. This is the examiner expected approach. This is what you are going to do from now on. It's essentially a visual story method combined with the PEAL framework. First, you explicitly write down the baseline formula you are using. Then you clearly state your assumptions. Next, you draw a large, clear free body diagram, carefully resolving the vectors into their sine and cosine components. Finally, you lay out your algebraic steps sequentially, line by line, moving down the page. This strategy encodes and contextualizes the mathematical concepts so beautifully clearly that the examiner can follow your precise train of thought from start to finish. It's basically handing them the marking scheme on a silver platter. Stop scrolling! Subscribe to our YouTube channel Ace the Exams at actheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's get into the tactical phase. Section 4, execution and problem solving. Understanding the theory is great, but it's only half the battle. Now we need to translate that physics theory into a standardized, repeatable procedural framework that you can deploy perfectly under intense time pressure in the exam hall. I call this the Mathematics Success Blueprint. This is your 5-step surgical procedure for attacking absolutely any mechanics question Cambridge throws at you.
Step 1. Deconstruct and identify the given information. This is your data scan. Don't just read the paragraph. Mine it for data. Extract the numbers. What is the mass? What is the exact coefficient of friction? Is the plane rough or smooth? Step 2. Apply relevant principles and select an analytical framework. This means making a conscious, strategic decision. For example, realizing that you must resolve forces parallel and perpendicular to a 30-degree inclined plane before doing anything else. Step 3. Execute the analysis with clear notation. This is where you write, and I mean write clearly. Don't use a messy lowercase w for weight if it looks like a lowercase omega. Be deliberate. Show every single line of your algebraic working. Step 4. Verify results for reasonableness. This is where you find the flaw in your own work before the examiner does. If you calculate the acceleration of a regular wooden block sliding down a ramp to be 900 meters per second squared, guess what? You've made a massive mistake somewhere. Stop, breathe, and check your assumptions. Step 5. Present with correct terminology and proper units. Leaving the newtons or meters per second squared off your final answer is a totally unforced error that just hemorrhages points. Don't do it.
What is truly fascinating about the 979 syllabus is how this exact framework scales up to handle higher-level problem solving, especially when you hit those nasty questions that ask you to evaluate or compare two different scenarios. Look at the evidence evaluation column here. To score in the top band, you must actively identify limitations in the mathematical models. For example, you need to explicitly state that assuming a string is light and inextensible or treating an entire car as a single particle are simplifications. You have to check those assumptions and mathematically assess how they might affect your final conclusions. Now pivot to the comparative analysis column. If a 6-mark question asks you to compare the kinematics of two different particles under different forces, you can't just list facts. You must identify both similarities and differences. You have to use strong comparative connectives in your explanation, and you must draw evidence-based conclusions about their relative importance. When comparative analysis goes horribly wrong, and it often does, it's usually because a rushed student missed the subtle similarities, only stated the obvious differences, and totally failed to connect their raw mathematical evidence back to the actual physical reality of the situation.
This brings us to our final and most critical section, Section 5, Top Examiner Warnings.
These points right here are the absolute gold dust. These are direct insights pulled straight from the official Cambridge Principal Examiner reports. Think of this as an autopsy of past exam failures, and we are going to learn exactly what mistakes to avoid. The top 3 ways students lose marks are as follows. Number 1, using the wrong approach for the wrong context. This is a classic trap. A student might try to aggressively force a constant acceleration kinematics formula, like v equals u plus at, into a scenario where the resultant force, and therefore the acceleration, is actually variable. You cannot do that. You have to match your mathematical tools to the specific physical environment of the question. Number 2, forgetting to check format and presentation conventions. Mathematics at the A-level standard follows incredibly strict presentation rules. We're talking proper headings, aggressively clear annotation on your free body diagrams, and using the universally appropriate format for your final answers, which almost always means rounding to 3 significant figures unless told otherwise. Number 3, providing answers that are not specific to the context given. Vague, generic answers absolutely do not score marks at this level. If the exam prompt specifically asks about a heavy wooden crate being pulled up a rough inclined ramp by a winch, do not give a generic textbook explanation about a particle falling through a vacuum. You must anchor your mathematics to the specific reality described in the prompt. This is the complete system: command word decoding, applying the PEL framework, and managing your time so you don't panic like Sam.
So, I want to leave you with a final, provocative question to think about as you prepare for your upcoming paper. Are your written answers truly context-specific? Or are you just throwing raw, disconnected formulas at the page, crossing your fingers, and hoping the examiner will somehow sort out the mess for you? To get an A-star, the surgical approach requires steady, deliberate intent. You have the full framework now. You know exactly what the examiners are desperately looking for, and you know exactly how to secure every single method mark along the way. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
Keep practicing those past papers, refine your technique, and I will see you in the next masterclass.